Today we're going to look at variation, which is talking about the relationship between two variables. There are three types of variations, and for each type of variation we're going to fill in the equation and then figure out how we undo things to solve for k. The first equation that we're going to look at is direct variation, and that's y equals k times x, because as x gets bigger, so does y. So they have a direct relationship. If I would like to solve for k, how I would undo multiplying by x is I would divide both sides by x. So k would be equal to y divided by x. The next equation we're going to look at is for inverse variation, and that equation is y equals k divided by x, because as x gets bigger, y gets smaller. So they're an inverse relationship to each other. If I want to get k by itself, how do I solve? Well, I want to undo dividing by x, so I would multiply both sides by x. So k equals x times y. The final variation we're going to look at is joint variation, and that involves three variables: y equals k, x, z. How do we solve for our k, our constant of variation? Is we're going to have to divide by both x and z. So k would be equal to our y divided by x and z. The next type of equation we're going to be looking at is how do I use these equations? What do I do with them? So we're going to take a look at a couple example problems. I'm going to show for you one for the direct relationship or the direct variation, and then I would like for you to look at the other two check it out problems, being number 5 and number 3 on inverse and joint variation. So I'm going to read the problem. First thing we're going to look at is the perimeter. Perimeter of P of a regular dodecagon varies directly as the side length S, and P equals 18 inches when S equals 1.5 inches. Find when P equals 75 inches. All right, first thing we need to do is take a look at that first sentence and write our variation equation from it. P varies directly with S. So we know P equals KS. The next thing they tell us is a combination of P and S that work together. So we know when P is 18, that S equals 1.5. We're going to use this equation to solve for k by dividing both sides by 1.5 to find our constant of variation, or find k. So in this case, k equals 12. Now I can write a variation equation that satisfies the perimeter for this regular dodecagon in terms of its side. So we're going to go ahead and take P for our perimeter of our dodecagon times our k, which is 12, times s. That's our equation for our variation. Next thing they asked me to do is to find s when P is 75. So we're going to use our equation that we just wrote, and instead of P, we're going to put in 75. Substitute 75 in. And we can go ahead and solve for s. I'm going to divide by 12 to undo multiplying, and find out that my side length would have to be 6.25. So 6.25 inches would be the side length for that regular dodecagon in order to reach a perimeter of 75. We'd like for you to repeat this process for problems number 5 and 3 of the Check It Outs. Remember to check your answers in the quiz in the app. Now let's take a look at your answers for the graphs of both direct variation and inverse variation. We should get an equation if we solve for k of y equals 0.5x. If I choose some values very carefully, I can go ahead and plot that line. I notice that my y-intercept is 0 and my slope would be 1/2, so I can go ahead and plot that line. Now let's take a look at your graph for your inverse variation. If you solve for k correctly, you get 40. So our equation for our inverse variation should be y equals 40 divided by x. Again, I'm going to choose some x values wisely to put in here. I would like to graph whole points, so I only chose the x values that would go evenly into 40. That's why I chose 4, 5, and 8, because they're factors of 40. You'll notice in my table that 0 is undefined, because that is going to actually be an asymptote for us for our inverse function. The last thing I'd like for us to do is do a little summary of what we know about our graphs. The graphs of all direct variation equations are linear, just like our equation that we graphed. Also, like our equation, our y-intercept is always going to be 0, and our slope is going to be our k value, or our variation constant. Finally, the graph of all inverse variation equations is called a hyperbola. And a hyperbola is made out of 2 pieces, and each piece is called a branch. So you see my 2 branches that are the orange curves up at the top. All right, now you should proceed on to work on your homework.